Bismillah ar-Rahman ar-Rahim. So today's lecture is going to be about text classification, okay, as it's written on the board. Um, so text classification, this goes back to when we started this course and we talked about discriminative and generative models. So this is the basis of all discriminative models. So classifiers are right in the middle of all these discriminative models. Right now, up until now, we have seen discriminative models which are rule-based or somehow using other techniques such as language modeling. Like, we are going to be, from now on, we'll be looking at classifiers for classifying text. So let me share my screen. So from today, we are going to be talking about text classification. ठीक है तो if you recall from earlier lectures, there are several areas in which we are actually classifying documents, especially from the introductory lectures. So let me give you some examples of classification. The spam detection is the type of classification in which you are looking at an email and you're trying to say, is this spam or is this not spam? So how is it happening? So features from the email. Can be used to detect whether it's spam or not. And these features may be like how it addresses you, what kind of cases it uses, does it use some spam buzzwords, all of these things. Another example of text classification is authorship attribution. Here, we are given a piece of text and we are trying to figure out, okay, who's the author of this text. Okay? So, for example, this is a real problem in the sense, okay, yes, you guys submit a lot of reports. Are you the author, or did somebody else author that document? Historically, it has been an issue. For example, who wrote the Bible? Who was the actual author? So anthropologists have been interested in these kind of things. For example, several parts of the Bible are written in totally different ways. So a person, he writes with a certain style, and the other person writes with a different style. And I'm not talking about the writing style. I'm also talking about the way words are chosen to be connected in the form of sentences. So they figured out, although they could not figure out who exactly wrote which piece, but they gave acronyms. So, for example, some part was written by E, some part was written by J, some part was written by P, and some part was written by this person named D. So, at least we can figure out which parts were written by each one of these people. See? Another example which we'll be using in detail is sentiment analysis. And I'll have another lecture on this sentiment analysis, perhaps with a good long example. So what is the problem of sentiment analysis? It is that given a review or a piece of text, you're trying to figure out what kind of sentiment it contains. Is it positive, I should- positive or negative, right? So, for example, restaurants and online businesses, they are deeply interested in what kind of reviews their products are getting. Now it's very e-commerce is so common. Earlier, it was just Amazon, and they have an entire review policy. Now it's Daraz as well. You also look at reviews when buying things online. So, for example, let's say there's a restaurant and it gets some online reviews, and you want to figure out, are these reviews good or bad, and what kind of service can we what kind of things can we improve to improve the quality of service or improve the business. So for example, you can get a review saying food is good, greatest burger ever, and you know, okay, this can be classified as positive. um, Bad food, worse service, and this can be classified as negative. However, there can be other reviews which can say by tasteless food, nice environment. Now, this contains both positive and negative, and perhaps can be classified as neutral. So, these are the things that we'll be looking at in this lecture today. Okay? Um, So generally, let me put down the general text classification problem. And we'll be talking about supervised text classification. So the text classification task is the task of assigning or categorizing any kind of text, or categorizing any kind of text into some given classes. So yeah, into a given set of classes. So if I formalize this a bit, so what you have as input is some text T, and you have a fixed set of classes, let's say C, which is C1, C2, let's say all the way to C of J. And the output that you want from a classifier is some class C from this set of classes that we defined above. Okay? So we can do this. We can solve this problem using rule-based AI systems. They can generally give us good results, but not always. And the big problem is that they are difficult to maintain and update. So what we are going to be looking at today is supervised learning, or is a form of supervised learning, or supervised classification. Okay? So what is supervised learning? Supervised learning is that we are given as input to the learner uh, a training set T. Let's say T, a training set of M hand labeled documents. So, so for example, let's say this T contains this set of documents. So it contains T1 with some class C1. It contains another text document T2 with some other class C2, and so forth until you have, let's say, T of M with some class Cm. So you have a set of documents which have been labeled with the class to which that document belongs to. So, for example, this may be a review, and this would be a class like positive, and saying that this review belongs to the positive class. Okay, so that's the input. The output is actually a learned classifier. Let me call it gamma. Gamma, a learned classifier. And we will generally call this a model as well. Okay? So this gamma is essentially what it does. It takes uh, elements from some text set and categorizes them from one of these classes in the set of classes C. So what that's what the model is supposed to be doing. And this, remember that this set is not equal to this training set. So instead, so to distinguish, I should say R. See? So let's say that this is a training set, and this can be this is the set of all documents that can be given to the classifier. So today we'll be looking at a simple classifier based on the naive Bayes equation. So we'll be looking at naive Bayes classifier, because it's based on the Bayes equation that we looked at the last time for the language model. So this is a simple classification method based on the Bayes rule that I'm going to write shortly. And this Bayes rule actually relying on the bag of words model. So bag of words, as you may recall from our last lecture, bag of words assumes that position of text or position of words in a piece of text does not really matter. So it ignores the position of text in the model. Okay? So what is this? Let me give you an example. How does this work? So let's say that you're looking at reviews, and there's a review that says, sadly, uh, this was a big disappointment. And you're looking at restaurant reviews. Uh, so the review says, sadly, this was a big disappointment. Terrible food, overpriced. So you went to a very expensive restaurant, and you figured out, okay, bhai, uh, this was way too much for way too much money for the amount of food and the quality of food that was given. Okay? So how would this work? How would the supervised classifier work? So in short, what the supervised classifier is supposed to do, which is this gamma. So let's say you have a trained classifier. It takes this entire review as a parameter, and it outputs some class C, which maybe from the classes positive and negative. So is it a positive review or a negative review, or there may be more classes. So we are right now looking at the simple classification technique, which is binary classification, classifying documents into two classes. Although this can be extrapolated to and multiple classes, to multi-label classification, and I'm going to talk about that in a couple of lectures down. But today we are going to be looking at binary classification. Okay? So how does this work? How does bag of word model work? So bag of word says, as I said, the sequence of words does not matter, and there is a list of stop words. So first, it says, okay, let's remove all the stop words. So this would be a stop word. Was let's say is a stop word. Um, let's say, okay, even food is a stop word in terms of reviews. Okay, food would be everywhere, and that would be it. So we are left with this bag of words. From this, we can get a bag that includes sadly and overpriced, terrible, disappointment, etc. ठीक है? So no, let me write all of them, and there is this big. So this is the bag that we got, and we're also looking at count. Okay, sadly appears once, this appears once, this appears once, this appears once, and this appears once, and so forth. So these are the frequencies of the words that are appearing in the document that are not stop words. So how does this classifier look at this review and creates a bag of words and classifies it as a negative review? So it would actually give, okay, bhai, this is a negative review, okay, as is visible. Okay. How does it do that? So for that, it uses this Bayes equation. So for some text T and some class C, what we want to predict is the probability of the class C given the text T. Okay? So we are given the review. We want to predict whether it belongs to the negative class or the positive class, and we would calculate the probabilities for both of them separately. Okay, what is the probability of this text belonging to the negative class? What is the probability of this text belonging to the positive class? And then we are going to see which probability is higher. So will be doing some sort of an argmax. So the thing is, directly calculating this probability is not easy. So we will be using the Bayes rule, which converts conditional probabilities into other conditional probabilities, which are which becomes the probability of this text T given the class C multiplied by the probability of this class C and divided by the probability of this text T appearing. See? Something that we looked at earlier for the noisy channel model as well. Okay? So the question is, how do we get the best class? Because what we actually want is this probability, the highest probability of class C given T. Okay? So as I said, okay, you'll be calculating, or we'll be calculating this probability for all the possible classes for a given text, and that means we'll be taking argmax over the classes, and we'll be saying okay, this is the predicted class, this is the best class that uh, we are our model is telling us. And then we are going to simplify this equation using the Bayes rule, as I said above. So we are going to be using argmax over the set of classes, and we'll apply Bayes rule and say the probability of this text T given the class C, the probability of C, and the probability of the text. So, as we did in the earlier model, the noisy channel model, you can see the text T is going to be the same throughout this argmax. Okay? So we can cut this off and we can simplify the equation further into argmax and say it's the probability of this text T given a class C and the probability of class C. Okay? So again, if you recall, I said okay, this is the likelihood probability and this is the prior. Okay, what are the chances of this class C appearing? I'm going to simplify this a bit further because we have this text T, and this text T is comprised of, uh, and we're saying that this text T is a bunch of words x1, x2, and I'm putting them in a set saying okay, let's say they're xn because we are using the bag of words model. So I'm going to be doing this argmax C from the class C, and I'll say the probability. What is the probability of word x1, x2, and these can be other features as well. Right now I'm just using words given class C. What is the probability of these words given the class C, and what is the probability of this class C itself? Okay? So there are a few assumptions that this naive Bayes model takes. I'm going to write these assumptions down before I expand this further. So the first assumption, as I said, is the bag of words assumption, saying that the position of words does not matter. Okay? And I'm going to tell you how it applies to this in calculating this probability. The other assumption is the conditional independence of words. That is, in general, naive Bayes uses these two assumptions saying that feature probabilities are independent. So as I said, okay, these need not be words. These may be other features of the text, such as xn may say, okay, this is the length of the text. X2 may say if uppercase was used, emphasis was made, and so forth. So these may be other numbers rather than text. So uh, what conditional independence means is that if there are two features, let's say x of I and x of j, then p of x of I, p of x of I given some class C, and the probability of x of j given class C is independent. So they are independent of each other, and that helps us in getting this probability. And how does that help us is in this way. So we can calculate the probability of this x1, x2, all the way to xn given some class C as the product of x1 given class C, the probability of x2 given class C, all the way to the probability of xn given class C, and that would be the product of all these probabilities x of I given class C where I goes from 1 to n. ठीक है? So that would mean कि in terms of our predicted class, I'll simplify this equation to say argmax over the set of classes, and I'll put this probability earlier, saying the probability of some class C multiplied by the probabilities of all the features given that class C. So I goes from 1 to n. ठीक है? So that's our naive Bayes model. And it works in a very similar fashion as our noisy channel model would work. So now the question is, how are we going to be learning this naive Bayes model? So learning parameters of the naive Bayes model. So for learning this naive Bayes model, we'll be, let me write that down first. So naive Bayes is predicting a class based on argmax over the set of classes. What you have is a prior, the probability of class C, and then a product. I goes from 1 to n over the set of features given that class C. ठीक है? तो we use the frequencies in data. So, yeah, which would mean okay, we are trying to calculate the prior of this of some class, and we would say okay, we would count the number of text with this particular class. ठीक है? तो count of texts belonging to this particular class C and divided by the total number of texts that we have. So here we are saying number of texts with class C, and this is the total number of texts. So that's our prior. So up till now we have calculated this prior. What is this telling us? It's actually just telling us, okay, what is the probability of this class? So let's look at the reviews. Let's say you have reviews. You have review 1, review 2, review 3, review 4, and let's say you have 5 reviews. Uh, most of the reviews, let's say they are positive. You have 4 positive reviews and 1 negative review. So the prior is telling us what is the probability of positive reviews. So in this case, it would be the prior for the positive class would be 4 over 5. It would be higher. Okay, the probability of having a positive review is higher. So the next thing is to compute these probabilities for the features. And in the case of features, we are talking about words. So the next challenge is to figure out the probability of some word I given a class C. Okay? In that case, we are going to be using something similar that we used for language modeling. So we're going to count the number of times this word I appears in this class, see, or appears associated with this class. And we're going to divide it by the total count of words appearing in that class. Right? So this is the sum of, let's call it J. Wj is the set of all words in this class C of j. So let me jot it down. So this is saying the number of times wi appears in class C. And this here is saying what is the sum of the number of words in class C. Total number of words that appear in class C text. ठीक है? So these are the two important things that we need to estimate. And these are the parameters of the model. So the parameters of the model are these things that appear in the equation, and we need to learn these parameters so that we are able to figure out the values for these parameters for unseen text. So now we are going to be estimating parameters. So parameter estimation. And as you know, कि भाई, parameters are being estimated. We are just looking at the given set of training documents, and we're estimating these parameters over those documents. So for the purpose of priors, that count is easy. Let's look at how we are going to calculate the conditional probabilities for the features. So we create larger documents for different classes by concatenating all the texts in that class. See? So in each class. For example, let's say कि I'm talking about reviews. So I have positive reviews and I have negative reviews. So I create a document for all the positive reviews. So this would be review 1, review 2, review 3, review 4. And then I create another document for negative reviews, and that would be review 5, review 6. Right? So we concatenate all the reviews in order of, or classified according to their different classes. Now we can use the frequency of words in these documents. Okay? But remember, as earlier, there are some words, and there are going to be many words. There are instances in which there will be instances where the probability of some word X for a particular class is going to be 0. What are we going to do with that? We are going to apply the same thing. So let's say, for example, we have a set of positive words, but the word fantastic does not come into the positive words. So we are trying to figure out the probability of fantastic in the positive class, and the count is 0. So we were saying this is going to be the count of fantastic in this positive document divided by the total count of words in the positive document. Okay. But since this is 0, the probability of fantastic given the positive class is going to be 0, and that's what we don't like. So what we are going to do is to apply Laplace smoothing. See, to apply Laplace smoothing. And by applying Laplace smoothing, we are going to be changing the way we are estimating the probabilities. So, for example, word I given a class C, we are going to say it's going to be count of word I in class C plus 1 and divided by the sum of all the count of words in this class C plus the entire vocabulary. See? Regardless of whether the word is in positive class or the negative class. So the entire vocabulary. Yeah. So this is the Laplace smooth probability for our features. So now we're getting into how are we going to learn or what's the learning piece in this naive Bayes algorithm. So learning in naive Bayes, or learning the naive Bayes parameters. So how are we going to learn the parameters? So this is what happens. We have a data set. Let's say we have a data set of reviews. We split it into training and test. Our learning is going to happen on these reviews, R1, R2, all the way to Rm. Okay, and they have been labeled. So they have been labeled as positive, positive, and whatnot. Okay. So our learning algorithm would involve using all these reviews that have been labeled here in the training set. Although there are reviews in the test set and they are also labeled, but we are not going to be looking at these for the training part. See? So let me write down the algorithm. From the training set, we extract the vocabulary V. See? And this vocabulary would be the combination of vocabulary from all the classes. Let's say V1, V2, and all the way to V of K. See? So these are for different classes. They may not only be positive, negative, neutral, and there may be other classes as well. So how is this learning going to take place? So first of all, we need to calculate. Let's take the easier one. Calculate the probability of the priors. Right? So what is the probability of the priors? For, let's say we have a loop for each class C. Let's say for each C in the set of classes, you do this. You take uh, we take text we create a text called text C, and we concatenate all the texts with this class. See? And we are taking the size of the text. So we are creating a set of these texts. So in that case, the probability for this class C would be the size of this set divided by the total number of texts. So essentially, if you're looking at this example above, we are for each class, for the positive class, and let's say we have positive and negative class, for each class we are going to be calculating a prior. So the prior for positive class and prior for negative class. And we are saying, okay, bhai, we gather all the text in the positive class into this set. We get the number of positive samples, and we take the total number of texts in the training sample. So let's say there are 10 positive sample and the total number of training samples is 20. So we'd get 10 over 20, and that would be the prior of the positive class, and similarly for the negative class. Okay? So that's calculating the priors. So this is the type of algorithms I would be expecting. Okay, bhai, you'll be able to write in your papers, in your exams. See? How about the priors? So the next thing will be calculate. Sorry, how about the conditional probabilities? So we want to be able to calculate the probabilities for each word I given some classes. See, so that's the next thing. In here, we are going to be creating separate documents. So one document, let's say for this class C, so this would be a single concatenated document of all texts in class C. So we get that document. Then we have a loop. We have a for loop for each word wi in the vocabulary. See, we are going to count the number of instances of this word in document C. So we count the number of times this word wi appears in document C. Okay? And then once this has been done for each word, we are going to calculate the probability of this word I for the class C by taking this count, adding a 1 to it, and dividing it by n. This is in doc C plus the size of the vocabulary. Okay? So this n is the number of words in the document, and perhaps I should just write it as doc C and that. Okay. So this is where we are calculating our naive Bayes parameters. So yeah, I was thinking I should do an example. Uh, let's, but before that, let's give it a comparison. So naive base versus the language model. So what's happening is that each class in naive base generates a separate language model. So it's doing something similar. So each class in naive base generates a separate language model, and that's what's happening. So by which I mean naive base assigns each word. So for example, word I, a separate probability for each class. Okay? So the same word would have a probability in class 1, the same word would have a different probability in class 2, and the same word would have a probability in, let's say, class M. So for every uh, class, it has a separate language model. Say, and the other thing, because of our the rules that we implemented, the way because of the assumptions of a bag of words, the sentences, the probability of a sentence given a class is being calculated as a unigram multiple. So for all the words in S belonging to that class. See? So for example, let's say you have a sentence, food was terrible. And let's say I'm not removing the stop words. So for the positive class, I have three words, food and was and terrible. And I have some probabilities. So the probability of each word appearing in the positive class, the food, let's say, appears with a probability of zero point 0.1, was appears with 0.05, and terrible appears with probability 0.0001. And then we would have a separate model for the negative class, the probability for each word for this belonging to the negative class, and we have the same words. We have food, was, terrible, and the probability of food appearing in the positive and negative class would probably be the same. The probability of was slightly different, maybe, but the probability of the word terrible appearing in the negative class would be much higher. Right? And when we are actually calculating this through our naive Bayes model, we'd be calculating, let's say, this is our sentence, let's call it a review. So this is our review, and we are calculating the probability of the review for the positive class. We would be multiplying all these probabilities of the words for the positive, and we'd say it's zero point 0.1 multiplied by 0.05 multiplied by 0.0001, and that would be 0.0001234505. ठीक है? And similarly we would be doing this for the negative class, and that would be the multiple of all these probabilities for all the words given in the review, in the same review, and we would be getting something like 0. 0.0042, let's say. मैं एग्जैक्ट कैलकुलेशन नहीं कर रहा, लेकिन इट टर्न्स आउट Okay, when you are taking argmax over the two, over these two values, you'll figure okay, this is higher, and the argmax is over the classes, so that would give a negative class as a result. Okay? So essentially, the probability of the of this review belonging to the negative class is higher than the probability of this review belonging to the positive class. See? So the more likely class uh, it is, the model will give us that class as output. So let me do a complete example, even though it's a short example. So let's say, okay, you have a training corpus, or you have a corpus in which there are some training sentences. So let's say you have text one says Chinese, Beijing, BEI, Beijing, and Chinese. Okay? And you have Chinese, Shanghai. In text 3, you have Chinese food. In text 4, you have Tokyo, Japan. Okay? So essentially, we are trying to, and they're labeled. So the labels are here. It says this is a Chinese thing, Chinese thing, Chinese thing, and Japanese thing. So you have a binary classification problem in which you are trying to distinguish things Chinese and Japanese in this short example. And you have test data, and let's say you have just one sentence in this test data that says Chinese, Chinese, Tokyo. Okay? And this has been labeled as question mark. Okay, you need to figure out okay, what is the label for this. Okay. So first things first, we are going to be using our algorithm to figure out the priors. There are two classes. In the set of classes is essentially Chinese and Japanese. So we need to figure out the prior for Chinese, which is looking at the training set. There are four examples, and three of them are Chinese. So 3 over 4, which is the prior for the Chinese, and the prior for Japanese class is there's one example out of the 4 in their training set. So these are our priors. Now getting on to the conditional probabilities, what we need are the probabilities for all the words that exist in our test set. Essentially, we can calculate the probabilities of all words. So the conditional probabilities, there would be two models. There would be a Chinese model and there would be a Japanese model. So we have a Chinese model and we have the probabilities for each word in this Chinese model. And let's say we just want the probabilities of the word Chinese and Tokyo. Right? Similarly, we have a Japanese model, and we want the probabilities of each word for the Japanese word. There are other words as well, and we are not going to be looking at them for now because we don't need them for our test sentence. So we need Chinese, and we have Tokyo. See? And there are other words such as Beijing, Shanghai, and food, Japan, and so forth. See? So how are we going to calculate this probability? See? The probability of the word Chinese in the Chinese class. So first we take this and concatenate all of this to make doc Chinese. See? And we take this and we concatenate it to form doc Japanese. Now, the probability of Chinese in this document would be the count of times the word Chinese appears here: 1, 2, 3, 4, 1, 2, 3, 4, 5, plus 1 for smoothing, and divided by the total number of words that appear in doxy: 1, 2, 3, 4, 5, 6, 7, 8. 8 plus the size of the vocabulary. Now, the vocabulary essentially includes Chinese, Beijing, Shanghai, food, Tokyo, Japan. See? So 1, 2, 3, 4, 5, 6. So this is 8 plus 6. And this turns out to be 3 over 7. Similarly, for Tokyo, Tokyo does not appear in the document C, so that's a 0 plus a 1 for smoothing, and the denominator is the same, 8 words appearing in doc C, plus the size of the vocabulary, which is 6, so this is 1 over 14. We do the same thing for the Japanese class. We take the word Chinese, look it up in doc J, the count is 0. We add 1 for smoothing, divide it by the total number of words in document J, which is 2, plus the total vocabulary, which is 6. So this turns out to be 1 over 8. The word Tokyo, look it up in doc J, it appears once, plus 1 for smoothing. 2 words appear in doc J, plus 6. So this is 1 over 8, 2 over 8. So that's 1 over 4. Okay, so now we have the required probabilities for the conditional probabilities to calculate the argmax. What we are going to be doing is calculating the probability of this sentence C5 in belonging to the class C, and the probability of T5 belonging to class J, and that's actually we will be multiplying these 3 times. So the probability of the word Chinese given class C cube, because it appears 3 times, and the probability of Tokyo given class C 1 time, and this would similarly be the probability of Chinese given class J cubed multiplied by the probability of Tokyo given class J. And this would turn out to be 3 over 7 cubed multiplied by 1 over 14. And this would be uh, 1 over 8 whole cube multiplied by 1 over 4. Okay, so let me summarize it up for you. This, sorry, I missed something. So the priors are missing. So not only this, we need to multiply the prior for Chinese here and the prior for Japanese here. And this prior was, let's see, what was it? The prior for Chinese was 3 by 4, and the prior for Japanese was 1 by 4. And we multiplied these with the probabilities as well. See? So that brings us to the probability of T5 given C is equal to, as I have computed, 0.0042. You can verify it. Then T5 given Japanese 0. It's a small number, 0.00012, let's say. It's a very small number. So if you take the argmax You take the argmax over the classes from amongst Chinese and Japanese for the probability of T5. This is the set. Let me explicitly state it. And T5 given class J. You'll see, okay, this is a bigger number than this. So it would pick C and return it as C. So this sentence T5 would belong to class C or Chinese. Right? So just a few points before I close off. Naive-based classifiers can use much more than just word features, as I said earlier. Okay, they can take the length of sentences, they can take the number of nouns, the number of adjectives, the length of words, and so forth. Say, naive Bayes is preferred for these simple problems because it's fast and requires very low storage and works in a very similar fashion as to the language models. And it generally works very well when the independence assumption holds. See? So naive Bayes works very well if the independence condition holds. See? So that's it for today's lecture. And thank you very much. I'll be taking any questions from here on.